Hey everyone, and welcome to This Explainer. I am absolutely thrilled to have all of you technical teacher trainees here today. Because, let's be real, as you get ready to step into your very own classrooms and labs, you're going to be facing a totally unique set of challenges. You aren't just handing out random facts, right? You're teaching the core systems, the laws, and the foundational principles that literally make our modern world function. So today, we're diving into a bit of a masterclass on one of the absolutely most powerful teaching tools you can have in your back pocket, the deductive method. So get comfortable, get focused, and let's start building up that instructional toolkit of yours.
So picture this scenario. It's something every single educator goes through, and I want you to put yourself right in this moment. You're standing at the front of the room. Your students are all looking up at you, pens ready to go. You have to teach them Ohm's law, or maybe the laws of thermodynamics, or some highly complex grammatical structure. How on earth do you take a massive, abstract, universal rule and actually make it click for a room full of fresh minds? I mean, do you just let them guess their way to the answer, or do you hand them the master key right up front? Well, this exact teaching challenge is what we're tackling today, and the solution fits perfectly into the highly structured method we're about to break down.
All right, here's our quick game plan for this explainer. First, defining the method. Second, the 5-step plan. Third, real-world application. Fourth, pros and cons. And finally, classroom roles.
Section 1. Defining the method. Let's get right into the core philosophy.
Okay, let's dive into this. The deductive method is officially defined as a teaching method where the teacher presents general truths, principles, or rules first, and then gives specific examples to explain and prove them. I really want you to focus on that direction of travel for a second. You are starting wide with the big, universal truth, and then you're narrowing it all down. You hand them the rule right out of the gate, and then you spend the rest of your lesson basically proving that the rule actually works.
To really get the vibe of this method, let's look at its defining characteristics. Like we just talked about, it fundamentally moves from the general to the specific. And because you're the one delivering that core rule up front, it's a very teacher-centered approach. You are totally driving the ship here. It's also heavily based on reasoning, which in turn develops serious logical thinking skills in your students. They actually have to take that rule you gave them and use pure logic to see how it applies to individual cases. And this is crucial for you as technical trainees. It's incredibly useful for subjects with well-defined principles.
Which naturally brings us to the ideal subjects where this method just completely shines. Just look at this list. Mathematics, science, grammar, logic. What do all of these have in common? They are all governed by strict, unyielding laws and principles. As future technical teachers, you're going to be living and breathing in the worlds of math and science. When a rule is a fixed, unchanging law, like gravity or a specific mathematical formula, the deductive method aligns perfectly with your lesson plan. You really don't need your students to creatively discover the formula for the area of a circle, right? You just need to give it to them and show them exactly how to use it.
Moving on to Section 2, the 5-step plan. Let's talk about actually building a lesson. Any great technical process requires a solid sequence, and honestly, your pedagogy is no different. So here is your 5-step plan. Step 1, the statement of the general principle. You simply put the rule on the board. Step 2, explanation. You clarify all the terms inside that rule. Step 3, application. You apply the principle to specific situations. Step 4, illustration. You provide some really solid examples and visuals to lock it all in. And finally, Step 5, conclusion. This is the moment where the students, having seen all those examples, fully understand and accept that original principle.
Now, what's really interesting here is how we can visualize that exact journey. You start with the general principle, symbolized perfectly by a light bulb, right? It's the big idea. Then you move through application and explanation, which leads straight into specific examples, represented by a magnifying glass. I absolutely love that imagery. You're taking this massive light bulb idea and you're using a magnifying glass to inspect how it works on a micro level. And that ultimately leads to the conclusion the moment it all clicks.
All right, Section 3, real-world application. Let's see what this looks like in the classroom. So, imagine for a second you're teaching an intro electrical or materials science class. You step up to the front, and for step 1, you write this general principle big and bold. All metals are good conductors of electricity. Boom, the rule is established. You haven't asked them to guess or share their feelings on the matter. You've stated a scientific truth to anchor the entire lesson.
But obviously, you can't just leave it there and walk away. You have to prove it to them. So you move right into your specific examples. You show them that copper conducts electricity well. And hey, maybe you point out that this is exactly why it's in the wiring of their homes. Then you show them aluminum conducts electricity well, then silver.
By taking that initial universal rule and filtering it down through these highly specific, tangible examples, you are leading your students to the undeniable conclusion that the overarching principle is completely true and reliable.
Section 4. Pros and cons. It's time to evaluate the method.
Let's weigh the advantages against the limitations, because every good teacher knows their tools inside and out. On the plus side, this method really develops logical thinking, it saves an immense amount of classroom time, and it heavily aids in retention. But you definitely have to beware of the pitfalls. It is for sure not suited for very young children who need that hands-on, exploratory play. There's also a very real risk that your older students might just become passive, blank-staring listeners if your examples aren't super engaging. And finally, it requires a genuinely well-trained teacher. You have to know your subject matter inside and out to pull this off smoothly.
Which brings us to Section 5, Classroom Roles, the dynamic between teacher and student.
Let's look at how these parallel roles build a really successful classroom ecosystem. Notice how your active role as the teacher directly triggers the exact response you need from the student. When you present principles clearly, their role is to listen carefully. When you explain with examples and illustrations, their job is to mentally process and understand the concept. As you guide them to apply the principle, they're observing the examples. And finally, when you check for understanding and give feedback, the students are actively applying and practicing the rule themselves. It's a highly choreographed dance, and make no mistake, you are the one leading it. And that brings us to our final thought for today. The source material summarizes this entire philosophy with a pretty fantastic quote. Deductive method develops reasoning, understanding, and discipline in students. Discipline is absolutely the key word there. By providing a highly structured, logical pathway from general truths straight down to specific realities, you are actually training their minds to process complex information methodically. So my question to you as you finish up this explainer and look ahead to your own future classrooms is this. Are you ready to master your subject matter deeply enough that you can confidently provide the light bulb and skillfully guide your students through the magnifying glass? Keep that question rolling around in your head as you continue your training. Thank you so much for joining me, and I'll catch you in the next explainer.